Hey, friends! It's day 164. Getting to the end. 16 actual days till the end of school. What? And then summer school. What? Fantastic. He's got to go potty. All right. We're jumping into electricity and magnetism. You know? You ever wonder why at night when you're in your bed and maybe you put your feet up. You put your feet up and you kind of like rub your hands on the blanket or you kick your feet against the blanket and you see these little lightning bolts. Looks like it looks like little lightning bolts. Well, that's static electricity, and you probably knew that already. But where does that come from? We're going to explore that. I'm going to teach you how to create or build up some static electricity at home with a few different objects and where it all comes from, what something called the triboelectric series is, what the triboelectric effect is, all kinds of cool stuff. Right, that explains why these things that you know, right? Like, you can take a balloon and go on your hair and it's going to stand up. Why? What's happening? All right, so we're going to get into that. So first, warm up. How many parts to the word electrostatic? Now, pause it and do the rest. If you're wondering what that sound is, let me show you.
I'm going to take the special oyster shells and pour them right here. But the duck pellets, they love it when we toss it into the duck pond. Watch.
Say hi.
Oh, there they go. Look how excited they
He's so psyched. It's barnyard time at school. Just in case you were wondering what's going on. Oh, cool. Okay. Okay, keep watching. I'm going to pause it while we talk. We're back? Okay. Luna and I finished our conversation. Electro, of or pertaining to electricity. Static, you remember that from kinematics. It means not moving. That's right. Nothing like a cherry Coke. Okay. Next part, a Coulomb. So a Coulomb is a unit of charge. It's named after a person. Coulomb was his last name. And so the Coulomb is about the amount of charge that passes through a 100-watt light bulb in about a second. Now, a 100-watt light bulb, we're talking about an incandescent bulb. And what do you think that would feel like if that much charge passed through your body in 1 second? You ever touched a light bulb before? How's it feel? It feels hot, right? So imagine if, and that's not even all the energy, right? That's just the heat energy, not the light energy. So imagine if some of that light energy, along with the heat, passed through your body for a second. It would probably hurt. It wouldn't be like getting shocked. Because when you get shocked from putting your finger in a socket, you're actually getting as much charge as your body can handle, right? As much as it'll take. And that's actually more than the light bulb can handle. So it wouldn't be as bad as getting shocked if you've ever been shocked before, but it would still hurt. Right? It'd be worse than touching a very hot light bulb. Okay, so moving on. Today, two things. I've got some guided reading on electrostatics. I want you to get familiar with electrostatics, so let's start there. And loading. Here we go. So we're going to define electrostatics. We're going to talk about what it is. We're going to define electrical forces. And we're going to think about what's inside, deep inside. We're talking about protons, electrons, right? What's inside the atom? Right? You know that there are neutrons and protons in the nucleus, that electrons are swirling around the outside. Right? You've learned that in physical science. But there's more. All right, we're diving deeper into the very, very small, into the atom to understand attractive and repulsive forces, because that really, in essence, is the nature of why we have electrostatics. So, lots of rules to think about. Here's something. We've got some balls and they're charged. And so I want you to put the charges that you would see here to make these scenarios happen. They're just hanging from strings, little spheres on the ends of strings, and they're charged. They're either both positive, both negative, or one's positive and one's negative. So think about how you could fill that in to make it be true. Moving on, thinking about neutral atoms. Think about what charge means. Think about how it is that people don't get sparked. And then finally, there's something called Coulomb's law, which is an equation. It's actually right there. And so what does that mean? What are the parts? Labeling the parts. What are all these parts? And that's the last thing we'll do with that. So this will take you a chunk of time. It's a good read to get a good foundation on electrostatics, which is the beginning of understanding electricity and magnetism. Okay, so what's static electricity? Well, cool. Great video for this right here. Excuse me, too much cherry coke. All right, we've done one or two of these before, lessons on TED Ed. So, a fun video about what static electricity is, right? Why is it that when you walk on this carpet, and you touch the doorknob, zap, where does that come from? So, here there are some thinking questions, 7 of them to be exact. And so you should, just like we did before, read these questions first. So click on them, and you can do this on your mobile too. So read each of the questions and then watch the video. Okay, so answer your questions in your notes. Don't type them on here. There's no way for me to check your stuff on the TED Ed website. So answer those questions there. And then to help you think about question number 2, I've given you some information here that when you're trying to make static electricity, it's better to have dry air. Static electricity is formed much better when the air is dry, aka the humidity is low. Here's why. When air is humid, water molecules can collect on the surface of materials, right, like this, and this can prevent the buildup of electrical charges. I'm talking about static electricity. It is cool. The reason has to do with the shape of the water molecules and their own electrical forces. You know about static electricity?
I used to know what it was.
You used to?
But I don't.
You forgot? That's okay. I can teach you again. Okay? Yeah. Okay. In a little while, I will post the answers to the guided reading, and you can take a look and check your stuff. Okay? That's it for today. Tomorrow, more electrostatics. Soon we're going to have you make some stuff on your own at home. And yeah, there you go.